Hello dear students, my name is Idris. I'm a physics teacher at Paris Private School. I'm going to record the 12th curriculum of physics and hope you get benefits from my lessons and subscribe my YouTube channels for the future videos. In this video from chapter 1 about the rotational motion and the law of gravity. So in this lesson you will be able to understand about the different types of motion. Like, for example, in chapter 1, section 1, the types of motion. How many types of motion do we have in physics? Generally, we have two different types of motion, rotational motion and translational motion. Like, for example, the rotational motion is a motion of an object about its axis, like rotating Earth around itself, and like rotating the Ferris wheel about a fixed axis. Another type of motion is translational motion. Second type of motion is what? Translational motion. And also the translational motion can be classified into three, The translational motion can be classified into three different types, like linear motion. You have learned in grade 11 about the linear motion. For example, when an object is moving on a straight path, okay? And another type of translational motion is a circular motion. Like, look, this is when a car is moving on a straight path. This type of motion is called a linear motion. Another example, another type of translational motion is circular motion. Like, for example, when the Earth orbiting around the Sun, the type of motion is a circular motion. Or, for example, when the electron orbiting around the nucleus, also it is a circular motion. Another type of translational motion is projectile motion. A projectile motion also you have learned in grade 11 in chapter 2, the projectile motion. Why we say translational motion? Because in a translational motion, the object's position changes continuously. For example, when an object is moving from one position to another position, this type is called a translational motion. Look at this, the linear motion. When a car is moving from on a straight path, its position changes continuously. In a circular motion, the same thing. Its position changes continuously, and the projectile motion is the same thing. But the main difference between translational motion and rotational motion, in rotational motion, the object can rotate at its position without changing position. Okay? So in rotational motion, the object spin or rotate around its axis, an internal axis. Now, rotational motion and the law of gravity, the definition of circular motion is a motion of a body on a circular path. In what path? Circular path. Around an external fixed axis. So what do you mean by an external fixed axis? It means that this object, when orbiting around this axis, there is a separation between the axis of the circular motion and the object. Like, for example, orbiting Earth around the Sun. There is a separation, there is a distance between the Sun and the Earth. Okay? So like, such as orbiting Earth around the Sun or the orbiting electrons around the nucleus. The rotational motion is a motion of a body that spins about an axis. But in that case, like rotating Earth around itself, its axis is located internal into the object, internal axis. The object rotating with the internal axis, not external, okay? This is the main difference between the rotational motion and translational motion. Such as rotating Earth about axis, internal axis, but in circular motion, external axis, okay? Or the motion of the Ferris wheel in an amusement park. Look at this example. This Ferris wheel, when it's rotating, its position does not change. So what is the type of this motion for the Ferris wheel? Its type is rotational motion. In this example, when the Ferris wheel rotating, where is the axis? Is located internal on the object. So this is the spinning object or rotating object around it is internal axis. So we have some notes here. Circular motion is a special case of rotational motion. What do you mean by that? What do you mean by circular motion is a special case of rotational motion? For example, in this case, this Ferris wheel is moving in a rotational motion, but by getting each point, like each chairs or light bulbs, undergoes circular motion. Okay. For example, what is the type of the motion of the chairs? Is a circular motion. Why? Because this chair is moving around an external axis. Okay, so that is why circular motion is a special case of rotational motion. Every point on an object that rotates about a single axis undergoes a circular motion that we studied, okay? Around that axis, for example, in a game city, the type of the Ferris wheel is rotational motion. However, the chairs or light bulbs on the wheel or all points on the wheel are moving around a fixed axis in the form of what? Circular motion. So a point on the axis of rotation has only rotational motion. This point that located on the axis of rotation, it has only rotational motion. It is not a circular motion. But the other points, by getting any point on the rotational motion, undergoes a circular motion. So that is why the circular motion is a special case of rotational motion. Now, for measuring the angular displacement and angular speed in a rotational motion, we need radian. What is radian or rad? An angle whose arc length is equal to its radius. An angle whose arc length is equal to what? Radius, which is approximately equal to 57.3 degree. So for the angular displacement, we have three measurements. For angular displacement, we have three measurements: rad, degree, and revolution. But for solving question in this section, in this chapter, we have to solve the questions with the rad, the angular displacement in rad. In the case when the angular displacement is given in degree or in revolution, you have to convert to rad. So the radian is a pure number. It means that it has no dimension in the SI unit. With no dimension, because theta is the ratio of an arc length, the distance, to the length of the radius, also a distance. The unit cancel and the abbreviation rad is substituted in their places. Okay? Theta angular displacement is equal to arc length divided by radius. Look, this is pi rad, y rad is equal to approximately 57.3 degree. Okay, look at this video. You can finding for half cycle, half revolution, and one complete revolution. When the object is rotate one cycle, one complete revolution, the arc length, according math basic, AS arc length is equal to what? The circumference of the circle. So the circumference of the circle is equal to what? 2 pi r. For example, in the case when for one complete cycle, if the arc length is not given, for one complete cycle, you have to know that S is equal to C. C is the circumference of the circle for one complete cycle. Okay? So is equal to what? 2 pi r. So in that case, S is equal to 2 pi r. And arc length S is equal to the circumference of the circle and is equal to 2 pi r. By substituting this equation, theta is equal to what? Arc length over radius. For one complete cycle, S is equal to what? C. C is equal to what? Circumference of the circle? 2 pi r. Replace 2 pi r over r. R with r cancel. What is remain? 2 pi rad. So for one complete cycle, how many rads do we have? 2 pi rad. So that is why 2 pi rad is equal to how many revolution? 1 revolution. 2 pi, 1 revolution is equal to how many degree? 360 degree. So it means that we can conclude that the 2 pi rad is equal to 1 rev and is equal to 360 degree. Like 1 revolution, 2 pi rad, also you can write 6.28 rad for 1 revolution. For half revolution, 1 over 2 rev, for half revolution, how many rads do we have? Only we have pi rad. This is half revolution. Okay? How many degrees do we have? 180. How many revolutions do we have? Half revolution. Look, this is 1 complete revolution, 1 rev, 2 pi rad, and 360 degree. 3 over 4 revolution, 3 pi over 2 rad, and 270 degree. For the half revolution, we have half rev and pi rad and 180 degree. For the quarter revolution, we have 1 over 4 rev and pi over 2 rad with 90 degree. The main unit that can be used for angular displacement is rad. Okay, but when the angular displacement is given in rev or degree, so we would convert into what? Rad, as follows. Convert degree to rad. How can you convert degree to rad? Okay, as you know, in this section or in this chapter, when you are solving the question to find the angular speed and angular acceleration, in the case when angular displacement is given in degree or rev, you have to convert to what? To rad. Okay? And sometimes it depends on the question. Sometimes the question asks us to find angular displacement in degree or in revolution. So that is why you have to know how can you convert between these 3 scales of angular displacement. Look, convert degree to rad. How can you convert angular displacement in degree to angular displacement in rad? So we have to find angular displacement in what? In rad. Make a fraction, okay? To find angular displacement in rad, theta in rad, okay, divided by, make a fraction. For 1 complete cycle, how many rads do we have? 2 pi rad. We have to convert to what? To degree. For 2 pi rad, how many degrees do we have? We have 360 degree. Multiply by what? Multiply by theta in degree. Okay? For example, convert 180 degree to rad. How can you convert 180 degree to rad? At first, you have to write down the equation. To finding theta in rad, write 2 pi. You have to get for 1 complete cycle. For 1 complete cycle, 1 complete revolution, 1 rev. How many degrees do we have? 360 degree. For 1 complete cycle, arc length is equal to what? Is equal to circumference. Circumference equal to what? 2 pi r. Replace into the equation of angular displacements S over r. S is equal to 2 pi r for what? For 1 complete cycle. What about for 2 complete cycle? Is equal to 2 times 2 pi r, okay? And divided by r. R with r cancel. What does remain? 2 pi rad. So it means that for 1 revolution, 1 complete cycle, we have 2 pi rad. This is constant and this is very important for the students to memorize it, okay? 2 pi divided by, convert to what? To degree, convert degree to rad divided by 360 degree, okay? Multiply by what? The angular displacement that given in the question, 180, okay? So in that case, theta rad is equal to 2 times 180, 360 pi divided by 360. 360 cancel. What does remain? Theta is equal to pi rad. So in this way, you can convert the angular displacement in degree to rad. Okay. Another conversion. Convert rad to degree. Okay. In the first example, we converted degree to rad, but in this case, we have to convert what? Rad to degree. In the case when the question asks us to find the angular displacement in degree, you need to convert the angular displacement in rad to degree. How? Like this. Theta in degree. So what is unknown? Angular displacement in degree. So you have to write in the numerator degree. Okay. 360 over what? 2 pi times theta in what? Theta in rad. In this way, you can, in this equation, you can find the theta, you can convert theta in rad to theta in degree. And also sometimes the student asks, is it possible to write, for example, we have shortcut here, 180 over pi? Yes, why not? Sometimes in the Wizari exam, they will bring like that. In which of the following way you can convert rad to degree? By multiplying theta and rad with 360 over 2 pi or 180 over pi. Both are correct. Be careful, okay? For example, convert 2 pi rad to degree. How can you convert 2 pi rad to degree? At first, you have to write down the equation. To find degree, what is unknown? Theta and degree. Make a fraction, okay? So our conversion is between what? Degree and rad. We have numerator and denominator. So, and also you know that for one revolution, we have 360 degree and 2 pi rad. So our conversion is, this example is between degree and rad. To find theta in degree, in the numerator you have to write down the magnitude of the degree. How many degrees do we have for one complete cycle? 360. And for the denominator you have to write down the rad. How many rads do we have for one complete cycle? 2 pi rad. Time is what? The theta that is given in the question. Theta in rad. Bring down this, okay? 360 divided by 2 pi times theta in rad was given in the question is 2 pi, okay? So theta in degree, 2 pi with 2 pi cancel, what is remain? 360 degree. So in this way, you can also convert degree to rad. Okay.